Year 11 homework 3 here. So first question is about displacement. It's displacement of halogens. Now the rule for displacement reactions is the most reactive element will always take the other ion. Okay, so the most reactive element displaces the least reactive element. Now that works with metals. We did it with metals in year 10, but it also works with halogens in year 11. So this is a displacement reaction. Okay. First question, what colour is the chlorine water at the start? Well, okay, you're watching this video and I've done a colour printout. I was too cheap to do colour in your books. It's black and white in your books, isn't it? You can see it's green. Chlorine water is green, okay? Why? Because elemental chlorine, chlorine in its elemental state, elemental chlorine is green. And that colours that liquid. Right, write a balanced symbol equation for this reaction. Well, I'm not going to do it for chlorine and lithium bromide. I'll do it for chlorine and sodium iodide. Sodium iodide. Now notice there's no formula given here, okay? So you need to work out the formula, not guess it. Too many students guess formula. Okay, well sodium, I'm doing it with sodium iodide, remember? Sodium is in group 1 of the periodic table. Therefore it forms the 1+ ion, Na+ ion. Iodine is in group 7 of the periodic table, so that means it wants to gain 1 electron to get a full outer shell. It's got 7 electrons in the outer shell because it's in group 7. It wants to gain 1 electron, therefore it forms the it forms the I- ion. So next question, are these positives and negatives balanced? Yes, the formula of sodium iodide is NaI. You must get the formula correct. Too many students guess formulae. You need to check that formula. So it is going to be chlorine. Now the halogens, when they're on their own, okay, are diatomic. So is oxygen, so is nitrogen, so is hydrogen. They're the only diatomic molecules. So when we write chlorine, we're writing Cl2, because it's diatomic, so the chlorine is on its own, plus NaI. Remember, I'm doing it for sodium iodide. You're doing it for lithium bromide. You need to do this on your own. Okay, arrow. Now this is a displacement reaction. The most reactive element always displaces the least reactive. So we need to know the order of reactivity of the halogens. The most reactive is at the top, the least reactive is at the bottom. It's the opposite to the alkali metals. The least reactive at the top, the most reactive is at the bottom here. So with halogens, most reactive at the top, least reactive at the bottom. Okay? The chlorine here is, in my example, the most reactive. The iodine is the least reactive. And the ion they're fighting over here is the sodium ion they're fighting over. So that's being passed around. Most reactive takes the partner, most reactive takes the ion. So that's going to be sodium chloride, leaving iodine on its own. Now you might write it like that, you would be wrong because iodine is a halogen, therefore it is always diatomic. It's absolutely essential we write these I2, Br2, Cl2, F2, O2, N2 and H2 when they're on their own. I2. Okay, get the formulae right, then balance the equation. 2 chlorines there, 1 chlorine there, we needed 2. 1 iodine there, 2 iodines there, we needed 2. 2 sodiums there, 2 sodiums there, that's now balanced. But that's not the answer to your homework because you're doing it with lithium bromide. Next question. What colour would the mixture be after the reaction? Give a reason. Well, it was green to start with, because of the chlorine. So the question now is, what colour are the products? Well, that is colourless salt water. Colourless. Iodine, now this is going to be, these are aqueous solutions. So let's put some state symbols down here as well. This was aqueous solution. Aqueous solution. These are dissolved in water. Iodine, in some liquid states, would be purple, but iodine in water, iodine aqueous, is brown. Okay? So it turns brown because the iodine is produced. Well, so when you're doing your example here, you need to find out what element's left on its own and then write down its colour. Okay? Why is this a redox reaction? This is a horrible question. Okay, it's really, if you can do it, you're working right at the very top end. Let's write out that equation again. Okay, I did it with chlorine and sodium iodide. Sodium iodide. Okay? And the products for my reaction were sodium chloride and iodine. Possibly you write out your equation again, okay? Balance that up quickly. Now, redox, reduction and oxidation. Let's remind you of that definition. Reduction So best to remember oil rig. Oxidation is loss, reduction is gain of electrons. Reduction is gain of electrons. Okay, so the question is, what is gaining electrons? Okay, oxidation, oil rig. Oxidation is loss of electrons. Oxidation is a loss of electrons. You may be wondering why I'm saying oil rig. Okay, it's a mnemonic to help you remember. Oxidation is loss, reduction is gain of electrons. Okay, that's why I remember it anyway. Oil rig. Oxidation is loss, oil, reduction is gain of electrons. Okay, so what's losing, what's gaining electrons? Let's have a think. Elements, neutrally charged, no charge, no charge. Here, it's the Na positive, Cl minus. So we've gone from no charge to a minus charge. The chlorine, no charge, negative charge. How did it get from there to there? Answer, the chlorine had to gain an electron, gain electrons. Okay, so what is gaining electrons? Is it oxidation or reduction? Reduction is gain of electrons. So the Cl2 molecule gained electrons. Cl2 was reduced. Okay. Next one. This was Na positive and I minus. So the I minus went to iodine. Iodine is an element. There, no charge. So we've gone from negative charge to no charge. How do we do that? Well, it was negative. So remember, the protons can't change, so only electrons can change. How do we lose a negative charge? We lose an electron because electrons are negative charge. So that's losing electrons. Losing electrons. What's losing electrons? Oxidation is loss of electrons. So the iodide ion was oxidized. Okay, because to get from minus to the iodine molecule, this is the iodine molecule. Molecules aren't charged. Elements are not charged. Ions are charged. To get from the iodine ion, the iodide ion, to the iodine molecule, we had to lose that electron. Oxidation is loss of electrons. So the iodide ion was oxidized. Next question. What mass of hydrogen chloride, well, let's immediately put a question mark on top of the hydrogen and chloride. What mass of hydrogen chloride is made when 8 grams of hydrogen, reacts with excess chlorine? Well, so we can cross that out because that's an excess. Okay, so we've got calculating quantities here. These are tough questions, so if you can't remember it, have a good look through the Year 10 book, but I'll go through it now. Okay, let's pick a different question rather than helping you doing this exact question. So the different one I'm going to do is I've just written it out here. I've tried to word it exactly the same way. Instead of what mass of hydrogen chloride, I've said what mass of magnesium oxide. There's my magnesium oxide, so I'm going to put a question mark on the magnesium oxide. Is made when 6 grams of magnesium, so 6 grams on top of the magnesium, reacts with excess oxygen, so we can cross that out, and I've got my relative atomic masses there. So it's exactly the same question as this, exactly the same method. You need to do it for your homework, I'm going to do it for this one. So stage one, okay, moles. There's 3 stages to this: moles, stoichiometry, moles. So I'm going to write them out now. Moles, stoichiometry, and number 3, moles. So the first thing we have to do is calculate the moles. What do we calculate the moles of? We calculate the moles of whatever we have got the mass of. Now we've got the mass here of magnesium. You've got the mass there of hydrogen. Now this says 2 mg. Okay, so I need the I need the relative atomic mass because to calculate moles. Okay, moles equals mass divided by relative atomic mass or relative formula mass, depending on whether it's an element or a compound. It doesn't matter too much, to be honest, with what you call it. So I mean, really I should write atomic mass here. Because we're dealing with elements, but I'll write MR forming mass. It doesn't matter. So the question is, what's the mass of magnesium? The relative atomic mass of magnesium, I should say. Now, so many students will tell me the relative atomic mass of magnesium is it's 24, not 12. Get it right, Phil. 24, not 12. The relative atomic mass of magnesium is 48. Because they say 2 24s are 48, and we're immediately going to get it wrong. Okay, and my question to them is, if they had a twin brother or sister and they wanted to know how much they weighed, would they have to get on the scales with a twin brother or sister? And the answer is no, that's ludicrous. This number here, this big number, is a balancing number. Okay, it does not tell us anything about the relative atomic mass of magnesium. The relative atomic mass of magnesium is found on the periodic table and is given in this question. Okay, so the mass of magnesium is 24. Okay, now in the question, the mass is 6. We know it's a mass because it's got a unit after it. So moles equals mass, that's going to be 6 divided by 24, in that case 0.25 moles. Okay, stoichiometry. Okay, so in my equation, I've got 2 mg makes 2 MgO. Stoichiometry, now we use these balancing numbers, these big numbers, and it's called stoichiometry. These are stoichiometry numbers. Okay, 2 moles of magnesium make 2 moles of magnesium oxide. So in other words, it's the same. Okay, we don't have 2 moles, we have 0.25 moles. We work that out here. Okay, 0.25 moles therefore makes 0.25 moles of magnesium oxide. So we now know how many moles of magnesium oxide we've got. We've got 0.25 moles. Okay, so moles, as we know, equals mass divided by formula mass. Well, we want to know the mass of magnesium oxide. That's what we want to know. So we need to rearrange this equation. Mass equals moles times formula mass. Now we know moles is 0.25, so we've just worked it out down here, 0.25. So now we need the formula mass. What do we need the formula mass of this time? We need the formula mass of the question mark here. So we come over to this side. So the formula mass of this is going to be mg. Okay, the MR of this now is going to be mg plus O. mg plus O, because the formula is MgO. We don't need 2 of them. We used the big number in stage 2. Don't use it again. If you use it again, you'll get it wrong. Okay, so there's 1 magnesium and 1 oxygen. Well, magnesium weighed 24, oxygen weighed 16. Okay, so that's going to be 24 plus 16 equals 40. 0.25 times 40. 0.25 times 40 is 10 grams. Okay, so that's how to do it, but that is not the answer to this question. You need to do it with those numbers and that equation. What pH does a solution of hydrogen chloride have when it's dissolved in water? Now remember, if a solution has hydrogen ions in it, it's acidic. If it has hydroxide ions in, it's alkali. Okay? This has hydrogen chloride is HCl, H plus Cl minus. You tell me whether that's acidic or alkali, and then give me a pH number. Test for chlorine. Test for chlorine just needs learning. Okay, very simple, very simple. You put damp litmus paper in it, okay, and which we've just seen here, it's acidic, so it turns red. Okay, but of course chlorine is also a bleach. What's bleach do? Bleach turns things white. Okay, so it turns red, then white. Okay, I'm not writing it down. You can get that written down. Write it out 5 times, get yourself tested on it until you've learnt it to death. Okay, good luck.